Hello all, I hope this video reaches you sound and safe. This is a physics past paper 2 to 3 years back. So let's see the questions out there for us, and please go quickly through the instructions when you have your past paper. Then okay, here is electricity. Figure 8.1 shows a circuit. Alright, this is the circuit that I have here. Okay, the lamp has a resistance of 3 ohms. Line XY represent a uniform resistance wire of resistance 6 ohm. Calculate the reading on the ammeter. Alright, in order to calculate the reading on the ammeter, we have to recap the rule which states that R is equal to V over I. V is the voltage and I here is the current. That's when I won't find the resistance, but here the questions wants me to find the current in the ammeter. So to find the current, I will just rearrange the rule for the resistance and everything will be fine. And remember that in series connection, the current is always the same throughout any point in the connection. That is in series. In pair, things might have changed to other forms. Alright, R is equal to V over I here. Rearrange to make I the subject of the formula. I equals to V over R. Here I will use the volts that from the power supply there, which is 12 volts, and I will find the total resistance here. Finding the total resistance in a series connection, it's easy since I have here R total will be equal to R1 plus R2 plus R3 and so on until, let's say, we have RZ there. Okay, this is the way to find the total resistance of a circuit when the circuit is in a series connection. Alright, let's get back to the formula I have here. So the total volt here is 12. So right, I is equal to 12 over the total resistance. Let's do that quickly down here. So I have the 3 ohm from the lamp, so 3 plus the 2 ohm from the resistor, so we have the 2 here, and I have the 6 ohm from line XY plus 6 here. That will be equal to 5 plus 6, 11. So total of 11 ohms. And the wire here is uniform, of a uniform resistance. What they mean here by the word uniform is that the wire XY has the same cross-sectional area throughout the length. Okay, so the resistance, I know that the resistance might be affected by the length, by the type of the material, the cross-sectional area, and so on. So here the word uniform, that means it has the same cross-sectional area throughout the length of the 2 meters there. So the total R equals to 11 here, so the ammeter reading will be equal to 12 over 11. 12 over 11 equals to, let's check the calculator here, So 12 over 11, that's equal to 1.09, which is 1.1. So my answer will be 1.1 amperes. Yes, because the unit of the current is amperes. Okay, let's see the next part here. Okay, part B, figure 8.2, sorry, shows the circuit with a different connection to resistance wire and an added resistor. The length xy of the whole resistance wire is 2 meters. The contact is made at Q, where the distance xq is 0.60 meters. As mentioned there, calculate the resistance of the circuit. Alright, here this connection is a mix between series and parallel. Alright, as I have the line xq is connected parallel with the resistor of 1.5 ohm. Let's see what we are going to do here. Firstly, let's get the value of the resistor of the line xq. Since resistance is directly proportional to the length, that means whenever the length increases, the resistance will increase as well, and whenever the line decreases, the resistance will decrease as well. So at part A, I have the resistance of 6 ohm and the length of 2 meters. Let's make a simple cross multiplication here so we can get the value of the resistance of xq line there. So let's say when it's 2 meters, it gives me 0.6, right, or 6. Let's check, it's 6 ohm. It gives me 6 ohm. So when it's 0.60 meters, it will give me x here. Okay, so to find x, that means 2x, simple algebra, equals to 60 times 0.60, and that x is equal to, that will give me 3.6 over 2, right? So x is equal to 1.8 ohm. Okay, so I have found the value of the resistance of the line xq. So now I want to find the total resistance. Okay, in the previous part I have written the rule for finding the resistance when the connection in series, and now let's see what we'll do when the connection in parallel. Okay, leave that there. And parallel connection, let's try it there. It's a different color. Parallel connection. Okay, the the rule says 1 over r total is equal to 1 over r1 plus 1 over r2 plus 1 over r3, and that will continue until 1 over rz. All right, so and there is a special case when there are only 2 resistors connecting in parallel, so our total will equal to R1 times R2 over R1 plus R2. It's just the same thing, but we have just cross multiplication and get rid from the two fractions and make it only a one fraction. Okay, so let's get back to adding the resistance together to get the total resistor here. So the 3 ohm plus the 2 ohm there, okay, gives me 5 ohm. That is series connection. That is series connection. All right, and and the parallel connection will give me I will use this rule here. Let's say this is 1 and this is 2 down there. I will use the second one, which is the R total gives me R1. Let's say the R1 is 1.5 times R2, which is the value that I get here, 1.8 over R1, which is 1.5 again, plus R2 1.8, and that will give, let's see the calculator here, 1.5 times 1.8, that will give me 2.7. all right, so answer over 1.5 plus 1.8. so the answer is 0.818 as shown on the calculator display, so it will be 0.82. all right, ohm, and that will be per connection here, and the total resistance of the circuit, here will be 5. So let's say total resistance will equal to 5 plus 0.82, and that will give me 5.82 ohms. 82 ohms there. Okay, that's all, I guess. Yes. So if you have any questions, if anything is unclear here, please write that down on the comment section below, and I will see it and we will discuss it later.